cloud.
Perfect. Welcome to React, an intermediate introduction. I feel like you guys have been using React for a few months at this point, so I didn't necessarily want to start from zero. So I'm kind of starting from one. We'll see how that goes. Some stuff I'm going to try to cover today, what React is and is not, why React, some of the concepts that make React unique, and then tying this back to some of the work that you guys have been doing the last few weeks, Dale's TypeScript talk last week, testing in general, etc. So what is React? React is a library for rendering user interfaces on the internet. And that's it. We covered this for those of you that were in SIL. We talked about this a little bit, this concept of React.createElement. So with React, we're able to represent HTML as JavaScript, which gives us the ability to do all sorts of complex things because JavaScript is a programming language. So we can create an element that is a div. We tell React, or we tell HTML what goes inside that div, which is the string hello world. And we can see that ends up in our HTML over here. We can also nest those calls. So I can put a paragraph inside of a div. I can apply HTML attributes to my paragraph tag. And again, I end up with nested HTML, and I end up with my attributes applied to that paragraph tag. I can also create custom components. This is something that is not necessarily possible with HTML because HTML elements are defined in spec. But with React, I can create these custom components that generate whatever custom HTML I want them to. And this is sort of the foundation of how we do everything in React, right? So I can create a custom greeting component that is actually just a paragraph tag, and I can apply my style. I can pass props to that thing so that I can have dynamic strings in it. Also worth mentioning that on these slides, you might notice that I have script tags here. This is not like a node project. I don't have dependencies declared. React, if you recall from Dale's talk last week, or the TypeScript in general, transpiles down into JavaScript that is displayed to the users as static HTML. I'm skipping all those steps and just grabbing the React JavaScript directly and putting it into my HTML document. Any questions before I move on? Excellent. React is not a framework. Some of the people, some of you folks on the call here might argue that I'm being pedantic when I say this. Dale has told me that I'm being pedantic more than once, and he's been right. I think the important thing to understand about React here, whether you call it a library or a framework, is that React is not opinionated about very many things. And it's not opinionated about what you call things, like what you call files or what you call functions, where you put them or how they interact with each other. That is sort of left up to the developer and the team. It doesn't deal directly with concepts like routing or testing or integration with APIs or other services or other libraries, but it's enhanced by those things. So for routing, for example, you can use the React Router library if you want to add front-end routing to your application. If you want to deal with state management in a way other than what React gives you out of the box, you can add something like Redux or Zoostand or MobX or whatever. And React integrates nicely with this whole ecosystem of other libraries. So depending on the room you're in, people get really up in arms about whether you call it a library or a framework. If you go to the React website, it says it's a library. Important thing to know is that as compared to alternatives, which are frameworks, it's not opinionated about very many things. If those opinions or that structure is something that you crave, there are frameworks that are built for or on React. Things like Next.js and Gatsby. These all have a lot of opinions about how things work together, where they belong, and what tools you use. So if that is something that you want, there are React framework options. And obviously this list changes all the time. This is just like what's popular right now. So why are we talking about React? The world has changed. Specifically, the internet has changed. When we first started doing this, when I say we, I mean me probably, and folks like Dale, the internet looked a lot different. The computers that people were using had significantly less processing power. The browsers that they used were different. There were different versions of different browsers and different versions of even the same browser. Internet speeds were significantly slower. We were all on dial-up or like, I think like 1 megabit per second when Fios first came out. Things were different. Cloud technologies in general have sort of changed the way that we think about where work happens. Yeah, Netscape, for example, is a great example. Cloud technologies have sort of changed things. So we have concepts now like serverless computing, functions as a service, edge computing, all these things that mean we don't necessarily need to do all of the work on the server. We can do the work where it makes the most sense to do it. So what that used to look like, I guess, what the internet, what web applications used to look like was very transactional. I would open my browser and go to a website, and I would request that website or I'd request that application from a server. If I wanted to do something as simple as like go to a new page, I would have to go request that new page from the server again. If I had any really complicated logic or database querying or anything like that, we would do as much of it as possible on the server and then send back a little bit of information to the client, to the front end, where interaction was really limited. But now that's not necessarily the case anymore, right? We do a lot of the data processing. We do a lot of business logic on the front end. And even the word server, the concept of what a server is not necessarily the same thing as it used to be, right? It might just be a Lambda function, or it might be like a node in my specific location, or it might be a CDN or whatever. So things look drastically different. And that's really why libraries or frameworks like React are so widely used today. There are some concepts that make React sort of unique within the ecosystem. And the first is that React is declarative. I didn't say it, I declared it. Does anybody know what I mean when I say declarative, or what the alternative to declarative programming is? No, that's okay. The alternative is imperative. Maybe you've heard of imperative programming. Declarative programming. Dale, can you give me 15 seconds on what declarative means?
Yes, declarative is when you don't, when you're working in a language it's such that you can tell the machine what you want it to do without telling it how to do it.
Yeah, exactly right. You don't give it step A, step B, step C, step D. You describe step D, and the language or the library, the technology fills in a lot of the gaps for you. If you were in SIL, or actually for those of you who are on Swarm who have been working on deployment manifests for PCF, that's another example of a declarative paradigm where you're describing the characteristics of a production deployment for the Swarm application, and Cloud Foundry is building out that infrastructure and platform and network configuration and storage and all that stuff for you based on your declaration. So React is similar, right? We describe two things. We have a state, and then we have views that react to different versions of that state. That's where the name React came from, for what it's worth, as opposed to telling the application specifically which steps to take when something changes or when the user interacts in a specific way. And that makes, as complexity of the application grows, or as complexity of our interactions grow, the complexity of the application itself really doesn't. Stays pretty static. I put an asterisk there because that is only partially, everything I just said is only partially true. React itself encourages us to write code declaratively, but doesn't enforce it in any way. And in fact, we do still write a lot of imperative code to describe the specific steps that we want, which is not necessarily a bad thing. So going back again to back in the day, we used to use jQuery. Has anybody, show of hands, anybody ever used jQuery? besides Dale? I know Dale has. Yeah, and Austin, yeah. jQuery used to be I'm gonna say the king of the mountain. It used to be the de facto front end JavaScript library. It was sort of like the only reasonable choice. And it's by nature very imperative. So this is an example where I have a button and I click the button, and then on the page, it just tells me how many times I've clicked the button. So when we're doing jQuery, we're doing that example with jQuery. First, we have to tell jQuery to wait until the document itself has rendered. So we have to wait until the document is ready. We have a button, this CSS syntax, so we're finding the button element on the page. We're registering a click handler so that when we click it, we increment a variable, and then we go find another div on the page or another element on the page, it's a paragraph, and we actually update the text of that element. So we're telling the page specifically, like, go find a thing on the page and change its contents in this specific way. As opposed to React, where we really only do two things, right? We declare a variable that is the count, and we increment that variable in state, and then we have a view that reacts to that change, and we don't have to connect those two things in any way because React handles it for us. Does that difference make sense? The second thing is JSX. Important to note that React is not JSX and JSX is not React, but React did introduce JSX. So they get tied together, but you can do React without ever touching JSX. And in fact, there are other libraries or other frameworks that are not React that use JSX. So they are distinctly different. In our first example, actually, let me start here. So JSX is, it stands for JavaScript Syntax Extension. JSX transpiles into JavaScript. So knowing that, based on what you guys talked about last week, can anybody tell me, does your browser understand JSX?
No, it would only understand the transpile JavaScript.
Yeah, exactly right. Your browser has no idea what JSX is or why you're trying to use less than as JavaScript. So in our first example, we talked about this React.create element concept, right? We're creating HTML with JavaScript. JSX is just an extra step in there so that the JavaScript we're creating looks more like the HTML that we want to end up in. They're only a little bit different, primarily because of two keywords, class and for, which are reserved keywords in JavaScript. I can't have a class because that means something, just like I can't use the word for, the keyword for, because that means something. So we have JSX that looks a lot like HTML, but not exactly, that transpiles into JavaScript that renders HTML on the page. The virtual DOM, can anybody tell me what DOM stands for or what it is? You guys deal with it every day.
Document object model.
That's right. Yeah, I think that's right. Document object model. I don't spell it out too often. I think it's document object model. It is.
Yeah, I don't spell it out often either, so I had to think about that a second.
Yeah. Ian, do you want to? Can you tell us? You have 15 seconds on what the DOM is.
To my knowledge, just kind of like what you're seeing on the page when you go to whatever browser you're looking at.
Mm-hmm. Yeah, that's true. That's fair. The DOM is it's a tree representation of HTML. So the HTML looks a lot like XML. And when a browser renders that HTML document, it parses it much in the same way that it would parse an XML document. So it breaks down your HTML string into nodes and attributes and elements so that it understands how everything relates to each other and where it goes on the page. The thing that became apparent as the JavaScript engine started to mature and like we started to build these more interactive capabilities is that doing dynamic things with the DOM is really slow. Parsing that tree and making changes to it like in browser and what the user is looking at takes a lot of time. So some would argue that the most impactful thing that React introduced was this concept of the virtual DOM, which is just a copy of that DOM tree in memory. So it can parse that thing in memory. It can make changes to it in memory and then synchronize those changes with what the user sees in browser. Significantly more efficient, significantly faster. It also gives us an abstraction layer for an events API. So React calls these synthetic events, just like the DOM, the virtual DOM or the shadow DOM is an in-memory representation of the document object model. Synthetic events are a pure JavaScript abstraction for native browser events. So things like I have an input box and I make changes to it. There is like things that are happening that the browser is doing based on that change, right? When I click the mouse, the browser is doing something. That implementation is up to each browser and it's up to each version of each browser. So depending on where your user is looking at your application, what settings are set or not set, you might have a different interaction, and React solves that for us. So it gives us a standardized events API so that in React, for example, when you write an onChange function, you can be confident that that code executes in the same way across any browser or across any device that it's running on, any different browser versions, anything like that. Does that make sense?
So just to make sure I'm clear on that, so the synthetic events, basically that's React's way of making sure, like, if I do an onChange, it will work no matter the browser or version or anything like that. So it translates what that onChange to whatever specific event would be used in each different browser.
Yeah, different browsers, even different element types. So if there are HTML elements that don't support specific event types, for example, or if there are different browser versions that have a different call signature for an event or don't support a specific event, React standardizes all of that. So we get like a consistent interaction with those events.
Okay, thanks.
Hooks are the next thing. Hooks are relatively new. I shouldn't say that anymore. Hooks are like, I think 2018 they're introduced, so they're not that new anymore. We used to write React components as classes, specifically when we wanted access to things like state and React lifecycle. So if I wanted, for example, if I wanted to fetch some data, like as soon as a component loaded or as soon as a page finished loading, which is a pretty common use case, I used to have to write a React class component in order to do that, in order to hook into that lifecycle. But people don't like classes in JavaScript, and the JavaScript sort of developer ecosystem, I guess, is very fluid. So we as an industry decided that we don't like writing classes, we like writing functions. And hooks were introduced as a way to give us those same stateful capabilities and access to React lifecycle events in stateless function components. So whereas before I had this like class components have state defined this way, set state, we got access to this use state hook. React classes have things like component did mount or component will unmount, lifecycle. We can access those in function components with use effect. Pros and cons to both, but generally it's a stat thing. One-way binding, have you guys heard or have you been interested in the concept of one-way bindings and two-way bindings? Probably not. So if I have a React component and that React component is a text input, if I want to make this a controlled, or if I want to make it an interactive component, there's two things that I need to give my code in that input. Can anybody tell me what those two things are? Or one of them?
Maybe a state and a way to handle changes to the state.
Yes, that is perfect. That's exactly right. I need to give it a state and I need to give it an onChange event that modifies that state when it changes. If you visualize this concept, I have an HTML, I have a React component on the page. When it changes, it triggers an event. That event updates a value in state, and the HTML element on the page reads that new value from the state. It is a one-way flow or a one-way binding. The alternative, which is popular in frameworks like Angular or Vue, use two-way bindings. is that I have HTML on the page that now I bind this element to a model. This is called banana in a box syntax, which is incredible. And then I have a class component that actually declares the class, right? And everything else is sort of magic. Any changes, I have a view state for my HTML, and I have a component state for my component. And behind the scenes, they sort of synchronize with each other for me. And if you visualize that, that is a two-way flow or a two-way binding. You can technically create two-way bindings in React if you're like directly accessing refs and like reading state that way. Do not recommend, but technically possible. There's other stuff, there's other stuff in here that makes React unique and interesting, stuff like server-side rendering that I'm not going to get into. My best recommendation, I'll provide some links to documentation if you wanna learn more. So I want to talk a little bit about React and TypeScript. So can anybody tell me where you most frequently use types in React? This is probably an opinion thing. There's not like an objective answer here. No wrong answers. Jonas, what do you think?
Use states.
I was just gonna say I use them all over the place.
Okay, that's fair. Use state is a good one. That's true. For purposes of I said there's no wrong answers, but I'm going to talk about props. So I guess there are wrong answers. You use types everywhere, but I would argue most commonly, like where it pops up the most, is in props. And I want to talk a little bit about what that looks like. Find the right one. Oops. So here we go. So this is just like a fresh React project with JavaScript, not with TypeScript. So you'll notice I have JSX extensions. I don't have TSX extensions. React and TypeScript sort of grew up at, yeah, text bump for sure. Grew up like around the same time. TypeScript was like not, I would argue TypeScript not widely used until like 2016, 2018. React was sort of still finding, well, its niche or whatever. So there was a good chunk of time where we used React without really using TypeScript. And one of the biggest difficulties with that is around props. So we sort of take advantage or take for granted right now, like if I have an element, I can very easily get at what things this component is expecting, what props this component is expecting, what those props are, whether they're optional or required. But in JavaScript, that's not as easy or not as possible. So I didn't do it. An open source library was published called prop types. And prop types are a JavaScript way of typing React props. So what that means is if I create a component, I'm going to do like components, and I'm going to say like greeting.jsx. I'm going to do a function here. So greeting, this is going to like return hello, and we'll take a name. So this is like super straightforward, just like takes one prop, says hello, whatever that name is. This actually, because I have ESLint on here, it's already complaining that I don't have prop types defined just because I have ESLint in this project. But if I come over here and I want to use my greeting, I say like greeting. So first thing is that like my React doesn't really know anything about this component. It doesn't know that name exists on props. It doesn't know what to expect. And you can see over in it renders, I just get hello empty string. So we come up with this concept called prop types. So I can define greeting.prop types. And I can separately, this is prop types dot string, capital P. So I can declare this separate object called prop types that tells my JavaScript in a TypeScript-like way what props to expect for this component. I can also, if I want to say it's required, for example. So now you'll notice in when I'm using the component, even though I have a required prop called name, where I'm using it doesn't know that at all. I have to actually execute my code to see in browser that I have a prop declared as required that's not being used. So this is sort of how, when we didn't have TypeScript, or when TypeScript wasn't easy enough to sort of use, or straightforward enough for most people to use, this is how we did this, and it's difficult to say the least. I can also define, I can say default props. So I can declare defaults, which I would normally do with TypeScript, but I can declare defaults separately to get it that way. So this is called prop types. This is how we used to do props in React with JavaScript without TypeScript. I think I get, yeah. Because of my tooling, I get a little bit more hinting here. But yeah, prop types. Does that make sense? Any questions? Of course, perfect. Testing. The test pyramid. If you have spent any time at all with Dale, I'm certain that he has introduced the concept of the test pyramid to you. The idea is that we have different types of tests. Some we have like unit tests. They are faster to execute, and we have more of them. Some of them, like UI tests or end-to-end tests or journey tests, are significantly slower, and we have less of them. And this is sort of like, it's called the test pyramid, right? If you are thinking about test strategy at all, or if this concept is interesting to you at all, and you Google the test pyramid, there are a ton of different representations of this concept. There's a bunch of different opinions. I'm showing this, I'm bringing this up because I'm about to talk about testing in the context of React, specifically of only React, sort of in a vacuum, which is a little bit irresponsible. So on your product team, as you're working, you should be thinking about testing within the full context of the product that you're delivering, and like the environments that you need to operate in and the users that you have, which I'm not going to do here just because I don't have time. A little bit of Dan opinion coming here. In React, what you should be testing, we should be worried about testing, are that your components render in different conditions. So if you have props, that your component renders in expected ways for all different combinations of those props, whether they're missing or they're something invalid or something you do expect. You should be testing that your components handle state changes in expected ways, and that your components handle user interactions in expected ways. I'm using plural components here because I'm not talking specifically about unit testing a component. It might be integration testing, might be testing like doing smoke testing or journey testing, multiple components, or the whole application or whatever. Things you should not be worried about testing are implementation details within a component or third-party libraries. This is Dale told me to tell you guys that React is suited for Chicago-style testing, not London-style testing. So yeah, thank you, Dale. Implementation details. So when we're talking about implementation details in React, there's stuff that happens inside of a component that is really hard to test. So for example, testing state directly, or you might have like private functions declared within your component or your class that you feel like need to be tested. And that is sort of a difficult thing to do with our current React testing strategies. You can technically mock the internal React state implementation. You can technically get at function declarations within the component. but I don't recommend. It's really complex and it's really brittle. And there is, I would argue, not a lot of value in testing those things directly. Do not recommend. Testing third-party libraries. So you guys use Material, for example. You don't need to test that the material text field component behaves in a way that you expect, because Material has tests that demonstrate that that component behaves in a way that you would expect. So you don't need to spend time or energy directly testing things that are the responsibility of third-party libraries. Now, the caveat there would be, this is like a custom input component. If you are passing props through to that third-party library, like if you have props on your component, you should still be testing those, but you shouldn't be worried about testing the third-party library directly. Do not recommend. You have all used at this point this tool, this library called testing library, which is aptly named. Testing library is a sort of the core technology at around front-end testing in 2023. It is what gives us like this isolated rendering, the user event. So if I want to interact with my components or interact with my application in a test, and then this grammar around how we find the things that have been rendered. There are implementations of testing library for each specific front-end tool. So there is React testing library, which you guys are using. There's also like Angular testing library, Vue testing library that hooks into those specific technologies. And then there are integrations with other test frameworks. So if you use Cypress for end-to-end testing, for example, you can use the Cypress extension of testing library in order to keep the same grammar and keep all the same concepts in the different types of tests that you're doing. I don't doubt that testing library will someday not be sort of the core of all the front-end testing that we do. But in 2023, it largely is. And that's because it gives us a way to test user behavior and user interactions without directly testing component implementation. So let's look at some more examples. All right, so there we go. So this is another project over here. So we have, this is just a straight Vite React TypeScript fresh out of the box. I didn't really make any changes here except for setting up some tooling. This is what it gives you when you first start, right? You just get this thing on the page, you click the button and it tells you that you click the button. But I want to add, I'm going to add some business logic here. And the business logic that I want is going to be when I click it one time, it says one times, and I want it to say one time instead of one times. I want that to look right. So I'm gonna add a function here. And this function is going to make sure that this reads the way that I want it to read. So if this is the number, time. Yeah, so it's literally just gonna, if it's one, it's just gonna return time. Otherwise, real simple business logic, right? So now you can see, cool. If I'm 0, I get, this works. Excellent. Okay. Oh, I do have a test for this. So I'm going to fix my test. Cool. So if I wanted to test this thing, as it is, this is like really awkward, right? I have a test that is like rendering my component on the page. And I don't really have a straightforward way to get at anything inside there. So if I wanted to test this thing, what would I do? How would I do that? Ryan, if you were going to test this, what would you do? If you felt like this needed to be tested?
Probably added another test for if it's more than once to see if it reflects times.
That's fair. I should point out that like I'm getting it by 0 here. I could do that, right? I could this is an assertion as well. If it can't find this element, it's going to throw an error. So I could, instead of expect, I could like user event dot clicked one time. I could do that. So this is I think the point that you're making, this is the way that we should be testing. We're testing user behavior. We're not testing the specific implementation of how this works. But if this were, let's say this is like actually complex business logic, and there's like something in here that I'm not really comfortable that this is appropriately testing. And if for whatever reason, I wanted to test this function directly.
You could use a unit test if you wanted to test it directly.
What would that look like?
So you'd probably have to create a new test describing get display text. And then basically give the so you have your describe block, you'd say something like it displays time when is clicked once.
Sure.
No, it displays times, and then basically you would have to test that function passing in the number 1 and then a number that should return times instead of time.
So how do I access this function in my test?
So you'd have to, so it's returning time or times, so you'd probably create a const, like call it return string or something like that, set equal to get display text, then passing in a specific number you're trying to test for.
So this is a sorry, the question I'm trying to get at. This is an internal function on my app component. It's not exported, it's not exposed in any way. It's a private member of that function. There's no way for me to directly test that thing because it exists in the context of my component. So in order to test this
Oh, so you'd
directly,
have to create an instance of app then to access that?
I'm sure there's a way to like app dot. Yeah, I'm sure there's a way to do that indirectly. One of the alternatives to testing library is called Enzyme. Enzyme used to provide, like through Enzyme you could do it. I haven't actually tried to do it in a long time. The TLDR that I'm looking for here is that you extract this function as a service. So if I pull out create get display text.ts, I can move this over here and export it. In my component, I can import it, and now I can write a unit test for this function easily, doing exactly what you just said, right? The complexity there is it's a thing that exists within the component. This is like sort of the first line of defense of I have business logic in my component that is not tested or is hard to test. The first thing that I always look at is, should I just extract this thing as a service so that I can test the service? We're going to get to maybe a more straightforward example of what that looks like in a minute here. Yeah, actually, I'll do that right now. So an alternative here. So maybe a more common use case is I have this component or this page, and as soon as the page loads, there's some data that I want to fetch in order to display on the page, right? I want to go to my API, get a list of things and display that list of things. In order to do that in a function component, there is a hook that I use. Does anybody know what hook you use to run code when the component renders.
That would be the use effect hook.
Use effect, that's right. So I have a use effect hook. This is technically a hook that runs anytime state changes. We're going to use it in this case for after the component finishes rendering. I am going to, so I don't have to write the whole thing over here. So I'm going to create this function called getData. GetData is going to call this API that gets a random image of a dog. And then I'm going to get data. And anybody know what this .then syntax is? Is this something you guys use?
It's the alternative to await, isn't it?
Yeah, it's called a promise chain. So async await and promises probably deserve their own hour-long thing. Async and await are a way of more I guess a way of writing promises more readably, more in a more functional flow. But use effect, actually, if I await, if I try to await async in use effect, React is unhappy. So there's a couple ways around that. You can declare the function and then just call it immediately after. I am, just for simplicity here, going to put it in a promise chain because it's happy with that. But this is saying call this function, which returns a promise. I know that because this is an async function. And then as soon as that promise resolves, I use this function to parse that response, essentially. So I'm calling getData. GetData returns this string, which is here. And then when I get that string, I'm going to set it as my dog. It would help if you guys saw what this actually looks like. It's literally just a JSON object, and the message is a URL to a dog, to an image. So down here, I will just add image source dog. Sorry, dog. There we go. So when my when my component renders, I'm going to get some data. And then once that data comes back, I'm going to put it into state. And in this case, the data that I'm saving is a picture of a dog. So same question as before. This is maybe less straightforward of a thing to test than clicking buttons, right? So clicking a button is sort of a known state or like a known interaction, right? I can render the page. I know what to look for. I know how I want to interact with it. And I know what I want to see after. There's two things that are different here, right? The first is that this is asynchronous logic. So if I try to test this, actually here, yeah, if I try to test this in the same way, when the component renders, there's no dog here because it hasn't gotten the data yet. And the second thing is that I don't necessarily know what it's going to go get. And I don't necessarily want network calls happening in my unit tests, right? Those are slow. So how would I test this? Let me ask it a different way. This is an interaction that all of the teams are doing, right? You have a component, it goes and gets data. So are you testing that right now? And if so, how are you testing it?
You'd probably want to mock it out.
Okay. Can you say more?
Sorry, say again.
Can you say more? Mock what specifically?
So you'd want to mock the network call instead of actually having it reach out to the network. Just return like whatever you decide. So for example, maybe just like go to that URL, grab an example JSON response and then mock the network call and just give it that JSON response?
Yeah, so that's a great answer. There's multiple answers to this question, and there's not. I would argue there's not a perfect answer. The first is we can do that. So we can mock fetch directly. Do I have that open? This guy. Sorry, I have it open somewhere. We can mock the fetch object directly. I don't have it open. So we can say when like the JavaScript or browser fetch, instead of calling this, I can like jest.mock that fetch and return, and I can write code to return directly what I want. That is an option. I think complexity wise, that tends to spiral a little bit out of control. If I want to change my API, or if I like decide for one reason or another, I don't want to use fetch, I want to use Axios, or maybe like one of the services I'm using releases an SDK that I can access. All of a sudden, all of my tests have to change. I'm also, if I miss something in my tests and I'm relying on mocking this network request, I might accidentally be making requests in my test, which if I'm just getting data are maybe not problematic unless I'm paying per request. But if I have requests that are like deleting data or adding data or updating data, that can start to become problematic. But that is one option. Another option, just like we did with that get display text, is I can extract this to a library. So if I extract this to a library, for example, client.ts, and I export it, I can import it, and now I can directly test. I can mock this get data module instead of trying to mock the network request. I can just mock the module that gets imported. And I'm using VI test over here, it's a lot easier. So I can just do, for example, I can just mock this module, and when I call get data, instead of actually making the network request, I can just resolve whatever value that I want. This is probably much more common. There is a third option that I'm not going to cover too much because there's some complexity setting it up. But the third option, there's two that I know of. This is it, MSWJS. The first is MSW. So you'll see this in a lot of open source projects. This will mock the actual network request or mock the response. So your tests are still going to make Swarm API client. Is that, yeah? Did you just mock that module, right? Is that right, Dale?
Yeah, I meant to send that to Ian personally, but yeah, this is exactly what we do with Swarm API client. That's the whole reason it exists.
Yeah, perfect. The third, so that the third option, I'm just going to talk briefly about. I don't have examples of. MSW and knock are the two examples that I know of to do this, but essentially sets up a fake server for your tests. So the client side code will try to make the request. The MSW or knock will intercept that request and send back a response, which is a lot easier than like mocking the fetch object, and you get sort of this mock server. It works really nicely, but like I said, there's some complexity in setting it up. I'm not going to cover it too much today, but I will. I'll give you some examples in the exercises I send after. Please.
Sorry, Matt, you might want to share some of your experiences. You had to do this a lot on the back end, right?
Yeah, with testing the CRID. Yeah, let me look that up.
So I didn't mean to put you on the spot. I just didn't know if you wanted to say a few things about that.
Yeah, I mean, it was pretty much like mocking the Trying to think of the words.
So remember when we specifically pulled some dependencies out just to make them easier to mock?
Yeah, I'm trying to think which dependencies it was.
These are the ones where we use currying. Sorry, I'm tanking your talk, Dan.
That's okay. I'm taking the opportunity here while you guys are talking. So the second thing I mentioned is that this is happening asynchronously. So the component loads, and then once our component renders, and once it renders, it's going to go do something to get the data that it needs. But our tests don't know that. Our tests are going to render the component and try to test what they see. So I'm just going to show what that means real quick. This concept of a test ID is something the testing library uses. So how do I do this quickly? Testing library is going to render the component on the page as HTML in order to try to test like the behavior that you tell it. And in order to sort of drive home not testing implementation details, the way that testing library gives you to get at elements that are on the page or that are on the screen are all of these get by or find by methods. And you'll notice they're like very sort of like user centric. So like get a, if you want to get a form element, you can get that form element by its label. If you want to get an image, you can get the image by its alt text. There's not, you can technically go do like document.find element by ID, but testing library is encouraging you to test by user behavior or what the user sees here. So that being said, there is one that we commonly use that is get by test ID, and we can define, where's my image? There it is, image. We can define in our component data test ID. You guys maybe have been using this or seen this image, which literally does nothing except give testing library a way to find this specific thing in tests. That's all that is. Get attribute source to B, and I called it I am a dog. So I'm going to run this test real quick. And it's going to fail. It's going to say, I was not able to find that element. And that's because that element gets rendered asynchronously after the dog is loaded, after the network request is made. So there's two ways that we handle this. There's two ways that accomplish the same thing. The first is we can use wait for that testing library gives us. So we can literally just wait for this thing to be true. So it'll render, it'll like go through the life cycle and do all of the things and just wait. There's like a timeout associated here. I don't know what the default is, but it'll wait for that test to be true. The other alternatives is instead of the get by, you can use find by. They're all the same. Like for anything, there is a get by, like get by title, get by whatever, find by, that same function exists. The only difference is that we can await find by. Let me grab this whole thing. This will be whatever. There's TypeScript things happening there. We can do the same thing here where we can await find by and it'll do the same thing. There's a timeout and it'll wait for that thing to be found. I like to use wait for. It's a little bit more straightforward for what I actually want to happen here. Questions?
Do they have the equivalent of something like this for like if you do a database call and you're getting like information back, can you do the same thing basically?
You can, so testing library itself isn't, that's actually a good question. I'm certain there's a way to do, you're talking about like wait for that concept specifically?
No, I was just thinking like, how do I, if I want to do a, test to make sure that a query gets me back data, and like if I'm building a web service and that web service goes to a database and gets the data, would I need, like, is there any type of mock-up tool that would allow me to like mock the database?
Yes. Yeah. There's a couple options there, and actually one thing that's pretty common in open source projects, I'm gonna harp on it a little bit. I in my previous job was making heavy use of something called Backstage, which is a Spotify open source like developer platform. And when you Backstage itself is database abstracted, so you can pick any database you want, and it builds itself on top of that database. So if you look at Backstage tests, they have a test database utility that tests all of their code in all of the databases. So it'll create like a mock Postgres database and test that. It'll create a mock Mongo database and test that. One thing I have seen, actually a pattern that I really like, is to use in-memory databases for tests. So especially if you're using a database abstraction layer, it's really straightforward to swap out your database driver. So if you have Postgres database for production, you can use like SQLite or whatever, use an in-memory database for tests, which is faster, and you get the same, like because they're using the abstraction layer, you get the same interactions. I'm gonna talk a little bit more, I think, about that in a minute here, and tell me if that scratches the itch, Adrian. Any other questions before I move on? Cool. So what else should we be testing? Extra, this is actually, maybe this is exactly what I was thinking of, Adrian. So if we have external services, and external might mean another team, it might mean an API that my team owns, it might mean like something else entirely, but we're getting data from somewhere and we're expecting that data, we're expecting certain things from that data. We're expecting like a timeliness of response. We're expecting like the data to have a certain shape. So we can test those things. It's called contract testing. You have established a contract with the data provider, and you can test that the data that you're getting, or the metadata, the shape of the data doesn't change or is what you expect. There's a bunch of different like methodologies for how to accomplish that, a bunch of different tools to how to accomplish that, but it's a concern where my application is relying on data. I want to be sure that it looks like what I expect it to look like. Visual regression testing. We want to be sure that like if I change like a base component, or if I make a style change or whatever to one part of my application, that it doesn't unexpectedly change another part of my application. If you've spent any time in the Jest documentation, you might have seen Jest snapshot testing, which is a thing, but also not a thing that I recommend, because it ultimately just tests if your components change, like if the way that they render change. And in my experience, everything always changes. So snapshot testing turns into tests always failing and just updating the snapshots so that they stop failing. And there's not a lot of value there. But there are visual regression testing tools that will like literally screenshot your application and do a diff and highlight specific areas that changed, which is a lot more useful. And then supply chain security. You guys, most of you have already started going through this, both KR and actually I think all three teams at this point, with the new pipeline that Adrian added. You as working on a JavaScript project, and actually most programming languages at this point, you are relying on dependencies. So you have in your package JSON, you declare a bunch of dependencies, and each of those dependencies have specific versions, and they have dependencies of their own. If you're releasing, especially in a regulated environment like the DoD, your dependency tree has to be approved. So you have to have approved versions of dependencies that you're using. You have to address security vulnerabilities as they crop up. There might be cases where you need to pin an earlier version. For those of you that were in SIL, we talked about colors.js, which if you recall, is an open source project that was extremely widely used that the maintainer sabotaged. So like the maintainer pushed a new version, sabotaging his own project that like broke a lot of things. There's a lot of different examples of types of things like that. Licensing is another one. Most of the stuff that we use, we assume we're free to use, but that's not always the case. And if you're using something that you're not licensed to use in your project, you might be opening up your organization or your company to a liability, which nobody's happy about. So there's these are just like some examples of other things, even specifically in the context of React, you should be thinking about. My sort of, whenever anybody asks me this question, at the bottom, this is like sort of how I answer it, is what's likely to change or what's at risk because of change? And that's something that you should be thinking about testing. I want to talk briefly about alternatives. I'm going to say like the ecosystem of front-end development in 2023. I'm sure you know that React is an open source library that was built and is maintained by Facebook. Angular is an open source library that was built and is maintained by Google. React is, I think I just said library, React is, or Angular is a framework. It's extremely opinionated and extremely structured, which some people like. It also makes use of two-way bindings, for example. It looks a lot different. It forces TypeScript, which React does not. Yeah, that's sort of like number two in terms of what's popular on the internet. Vue is number three. So if React is maintained by Facebook and Angular is maintained by Google, this need sort of arose to have a true open source alternative that would not put us at the mercy of like some giant corporation, which is when Vue became popular. It looks a lot like Angular, candidly. It uses two-way bindings just like Angular does. But it's also it's more the developer satisfaction or whatever that metric is. People like using Vue more than they like using Angular. There's others. Preact looks a lot like React, but it's focused on bundle size. So I think the entire Preact bundle is something like 300K. Svelte is super popular. Lit, I mentioned like at the very beginning that you can't create custom HTML elements, which is not true because there is a W3C project called Web Components, which you can look up. And Lit is a framework that's based around custom web components. So you're actually defining custom HTML elements that the browser uses natively, as opposed to JavaScript, pure JavaScript representations of those things. So it's super interesting. TLDR, why should I be using React? Maybe you are using React because it has excellent community support, which it does. It is by far the most popular and most widely used of all of the alternatives. Maybe it's what your team is comfortable with or familiar with. Maybe you work in a regulated environment and it's approved, whereas another alternative that you might want to use is not approved by security, I mean. Maybe you like its lack of opinions, or you like the syntax, or you like the way that it's structured, or the lack of structure. Or maybe your enterprise uses it, your organization uses it, you have shared services, maybe like hooks into your authentication provider, maybe like a style library that everybody uses for consistent styles. There's a ton of reasons that that you should pick React or not pick React, but it is not objectively better than any of the alternatives. And you should use React because it makes sense, not because you think it's better. Questions?
So comparing React to some of the other alternatives you had mentioned, I guess what are the main differences and why you would use React over, for example, Angular or Vue or Lit, besides kind of like comfortability, what your business is using, etc., in terms of like how they actually behave, I guess.
I would argue there are no other differences. And that's like, there's an asterisk there. There's stuff, I think at the scale that you guys are working at in the DoD, there is no difference. There are certainly going to be, like, if at any point in your career you go work at, well, if you go work at Facebook, they're going to decide for you. But if you go work at, you know, for some product company and you have like tens or hundreds of thousands or millions of daily users, or you have like really complex user interactions where performance starts to become an issue, or like controlling specific things that get painted on the screen or timing re-renders, like those sorts of things, there might end up being differences. Certainly not any that I'm qualified to speak on. This is like, I feel very strongly about this slide. There are not, as far as like user-facing functionality in 2023, there is not an objective reason to pick one over the other.
Awesome. Thank you.
Any other questions? Cool. You guys will get some stuff to read and some exercises later today. And as always, reach out to your coaches, reach out to me directly if you have any questions.